Good morning, good day, good evening, whatever time do you have, dear friends. My name is Anton Kuniluk, and today we continue our video blog series. Today I have a special guest. This is Avi Alkobi from Mellanox. Hello, Avi.
Hey, Anton. It's great to be here. Great.
Thanks for coming. So the topic that we have decided to discuss with Avi this day is one of, I think, very important and interesting what is happening in the network industry, not necessarily in the data center world or service provider world, but everywhere. We're speaking about the open networking. So Avi, what is open networking?
Wow, so that's a great question. I will try to answer it through the session. I think that people, when thinking about open networking, think about different topics. I will try to focus a bit on my area where I am actually working, which is more the data center. But there are different answers, and through this session, I will try to answer
them. Amazing. Let's get started.
Okay, cool. So let me share. Let me see. Okay, I think it should be okay now, right?
Yeah, we can see your slide deck. It looks good.
That's great. So Anton, first of all, thank you very much for inviting me. Kalniuk.com webpage and blogs. I think, me personally, I definitely learned a lot from your site and your knowledge. So thank you very much for that. And I would like, first of all, to present myself. I'm not going to pitch about my company, but just to present myself, where I'm coming from a company called Mellanox Technologies. It's a company that exists from 1999. It started as an AC company. First in a technology called InfiniBand, then moved to NIC cards, ASIC switches, then systems. 30,100 employees worldwide, so it's quite a solid company. This is where I'm coming from. And you started, Anton, by asking, what's open networking? So
exactly.
So people kind of think about open networking. There are different things that they're thinking about. Some are related to logical networks, some are related to physical networks, some are more on the data center, some more on the telco environment. Some are really not relevant anymore. For example, OpenSwitch is not really relevant. Some started as a server project, some software projects, some hardware. So really different domains. And the answer of this question, people will say maybe disaggregation, white box, bright box, Linux, obviously, non-locking, open source. So to answer what's open networking, it's actually everything, all the above. But on this session, because my expertise are on the data center, I'm going to focus about data center open network. So open Ethernet.
Okay, yeah, let's get started. Actually, among these words, as far as I see, that even some abbreviation, I don't know, something like bright box. Okay, white box is quite, usual one, but what is a bright box?
Oh, that's a very good question. So I will try to answer it later on, but I would say that basically bright box is a white box that comes with a software IP. The company behind the box actually comes with the knowledge also about software. So this is kind of I highlight what's the difference.
Okay.
We'll try to go deeper dive in this really these differences between white and bright.
Okay, cool. Sounds promising.
So I said I'm not going to pitch about my company, but I want to say something very important about open networking before we go to the software side. So open networking actually starts from the hardware side, actually. What do I mean? So Mellanox is kind of unique in the way that it's actually doing networking end-to-end, means that we are starting networking basically on the NIC card, PCI to PCI. So there's the NIC, cable, switch, cable, NIC card.
Okay. And everything what in between.
But the thing is, although we are actually designing, producing all those products, there is no locking in the sense that you can use a vendor switch, but another vendor a cable. That means that we are not, for example, locking cables. and we're not locking the NIC to the switch, and we're not locking any part of the hardware to the other part of the hardware. So, and this is very important, saying that open, everything is open, that's cool. But if at the end of the day, you are locked to a specific vendor from the hardware perspective, that's not really open. And the other thing is that, we can say, yeah, sure, you can use this switch with the other cable, vendor cable, and that will work fine. But then if you connect it, it will not work, then it breaks all the open, story, obviously. So we need to make sure that everything is actually working. And the way that it's going to be is that, first of all, the first thing, be as close as possible to the standard RFCs, protocol, and everything. And the second thing, which is even more important, a very vast and intense interoperability test. It means that, actually making sure that this open device is connected to Cisco, is connected to Arista, is connected to Juniper, is connected, whatever other vendor is out there is actually is going to work and not going to break.
Yeah, okay, yeah, fully agree, because I have seen many times myself when we need to buy this particular part number with this switch in order to make it working. Like what? Why does this amount of piece cost like another boy? I don't know, another switch. So it's really, just highlighting this point is really, really important. It's cool that you are doing this, guys.
Good. And I must say, it's a tedious work. It's not really easy, but there is no other way. You can say open all the time, but it doesn't mean, it means eventually that it should work in an environment which, can also be interoperable with it.
Okay.
And now if we drill down to the networking part, basically the switch, then if you go bottom up, there is the hardware part, the switches, the systems. And you mentioned, Anton, bright box and white box. Those are basically the bright box and white box switches. So what is the difference between white box and bright box? White box basically means only hardware. It comes typically for ODMs, vendors that are expertise are basically building switches, power supplies, putting the ASIC inside, putting the fans, building the system, building the PHY. And it doesn't include any part of the software. It's just the hardware. Those are what we call white box vendors. And then there is the bright box. The bright box means that it's basically the same thing. It's a hardware with no software, but the company that actually delivers the product has some kind of an IP and knowledge about software. If I can give you kind of an example, means that if you are picking up the phone and calling the vendor, the bright box vendor and the white box vendor, and asking them, okay, what's BGP? He has no idea. But if you're asking a bright box support guy, what's BGP? He knows. Typically, it's because the bright box vendors also have their own operating system. Okay, so this is the difference between bright and white box.
So that Mellanox per SE would be a bright box, because I know you have your own software like Mellanox Onyx.
That's correct.
Okay. So you don't want to be white, you are bright company. Okay.
Okay. And on top of that, there is the bootloader. And I think the standard one and the one that is most common, I think, in this open Ethernet environment is called ONI. It doesn't have to be, by the way. In some options, you can actually use Pixie boot.
Okay.
But the most known one and the standard one today and used one is actually ONI. And on top of that, you are actually installing the software. And software basically includes different layers. The first layer is called SDK. This layer is actually the layer that is activating and controlling the ASIC. It's the ASIC vendor API to basically control the ASIC and get information from the ASIC. And on top of the SDK, well, I will skip the SI in a second. I will explain afterwards what's a SI exactly. But on top of that, there are the different and explain, in general, what's each one of them. But we have for example, Mellanox Onyx. This is our own operating system. Cumulus, Sonic, and we'll talk a bit about also Dent and SwitchDiff.
Okay.
Now let's drill down again to the software component and look at the block diagram. So this is a block diagram of any switch, well, almost any switch in the industry. It will always be built off, as we said, hardware, operating system, and network applications. A typical network application for a switch will be a CLI, or a GUI, or SNMP or TACAX agent or whatever, different applications.
Okay.
And if we open a bit the network OS and go and drill down again and see the block diagram then. So we talked about the vendor SDK, this part of the code, which is kernel end user space that is controlling the ASIC. On top of that, there may be an abstraction API. Again, I will explain again what this means later on. On top of that, a forwarding agent, which is basically a bunch of code that is controlling or activating the SDK. For example, probably there is a module there that is called port that is describing the port abilities of the ASIC, or VLAN, or lag, or whatever.
Okay.
Different modules, software modules. On top of that, there is a protocol stack. And this protocol stack is responsible to activate protocols like BGP, OSPF, spanning tree, and different LLDP or whatever, different protocols. Okay, and everything here that I mentioned is actually running on top of Linux. Almost every operating system out there, no matter what, if it's Cisco, if it's EOS, Nexus EOS, Junos, Onyx, Cumulus, whatever, there is always a Linux beneath. Does it mean that it's an open network? No, we'll explain in a minute why not, but there is always Linux beneath.
Okay, sounds interesting, really.
Now, if we go, and I will try kind of to describe the different options. So if you go left to right, the traditional NOS, for example, Mellanox Onyx, but again, it can be EOS or Nexus, are what we call closed operating system, black boxes. And you see, as much as you see red, it means that basically the box is locked. What does it mean? It means that there is a kernel, obviously, there is a Linux beneath there. There is a forwarding agent, there is a bunch of code, but everything is actually, it's a proprietary code from the specific vendor. Also, the protocol stack on top is a proprietary package. It can be based, by the way, on some open source, but it's not anymore. So there are different protocol stacks out there. I will talk about FRR, which is the Linux kind of a branch of Quagga, which is the open option, but there is Metaswitch, and there is a specific protocol stack of Cisco, and there is a specific protocol stack of Mellanox. Everything is kind of locked, and we see lately, not really lately, that all those operating systems, including, by the way, Onyx, expose a Linux a bit. So for example, you can actually run a Docker container on Onyx, for example, and get some Linux out of it. And you can do it on EOS, and you can do it in other operating system. Why? Because remember, beneath there is Linux. Does it mean that it's open? No, it's not. Okay, and I'll explain in the second why. And the second option, if you're going in a bit right, is the commercial NOS, which is based on Linux. And I gave an example of Cumulus because I think Cumulus are the leaders in this domain today. So what does it mean? It means that there is a protocol stack. It is open source. Cumulus are using FRR, used Quagga before. But still, it's not fully open. Why? Because there are different vendors that Cumulus support, hardware vendors, and there is a hardware compatibility list, obviously, and each one runs a different ASIC. If it's Tomahawk or Trident by Broadcom by different vendors, or Spectrum by Mellanox, or other ones. And by that, it means that there is a component inside Cumulus which is proprietary, and it's dedicated to the specific hardware vendor. Okay. So it's not open source, but it is based on Linux. Now, I mentioned that we can expose Linux on the traditional NOS, and we're doing it. And on the other hand, with Cumulus, for example, it's based on Linux. It's basically started as Debian Jessie, only Debian Jessie Linux API to control the switch. And on top of that, Cumulus added applications like NCLU, which is their CLI, and also GUI eventually, and so on. So you can think about it, right? Okay, so I have CLI with Cumulus, and I have CLI with Onyx, and I have Linux with Onyx, and I have Linux with Cumulus. So it's the same. No, it's actually totally different. This is very important to explain. The reason it's totally different is because I'm a software guy, software engineer from the beginning, and I know that there is a huge difference between a system that was built from the beginning, architectured from Linux as an open platform, and then on top of that, creating applications one of them is a CLI, just one, right? There are other applications you run, versus a system that from the beginning was built to be closed and protected from the user, exposing only CLI and then opening Linux. It means that you're actually not getting the full power of Linux out of the traditional NOS because the vendor still needs to protect the system from the user. This is kind of a general concept why it's so different.
Okay, and we haven't touched it yet, the third one, which is completely open NOS.
Correct. So if you're going a bit on the right, we're going to the open NOS, and in this example I brought Sonic because I think it's the most, let's say, matured open source network operating system today for the data center. There are other options, but I think it's the most mature one. What does it mean? It means that you see everything is almost green. There is a bit of orange. I'll explain in a second why. But still there is a portion of red. What does it mean? It means that let's call it 95% open or 99%. Let's not go into the details here. And the reason is that still Sonic support different hardware systems. So there are components inside the network operating system that are dedicated to the specific hardware vendor. But it's not really important because today, for example, Sonic support, I think, all the platforms in the industry, at least the most significant ones. By far, it covers almost everything. So it's not really important. Let's call it 97% for the sake of argument. Now, there is the SCI part, which I want to talk about. The SCI part is a project that was created exactly to solve the problem of the dedicated SDK per vendor. That means that, let's say there is Mellanox and there is Broadcom, again, as an ASIC vendor, not as a system vendor, Broadcom and Mellanox. And then each one has its own SDK. Now it's very simple. For example, if you want to set an MTU, for example, in the Mellanox SDK, let's say that the API is S6 Mellanox set as the MTU with some parameters. And if you want to set the same MTU in Broadcom, it's called Broadcom set MTU. It's simple as that. Even the name of the function is different, and the variables may be different. So there is a very small company called the Microsoft that created Sonic. And obviously they don't like that because it means for them that they needed to port the code every time to different SDKs. And for that, they created together with Mellanox and then Broadcom the concept of a shim layer, basically an abstraction layer. And let's call it now the same MTU API, let's call it SCI set MTU. And each vendor will decide exactly how to implement it, but it doesn't matter from the application side, from the Sonic side, it's the same MTU for all vendors. And this is why basically it's created. Yeah.
So does it mean that Sonic does not need to operate directly on the ASIC kernel drivers? Would you say like is this dark part? I mean, taking care about implementation of particular command of particular vendor platform, but rather working on this abstraction layer on instructing like potentially all the underlying components in the same way. And it's up to hardware vendors how to map these SAI commands or instructions into their internal drivers, or
100% correct answer, yes.
Okay. And just, I mean, like a side joke, Microsoft, who's, creating the most closed system, they developed Sonic, which is the most open system. Something has radically changed their mind, which is good for industry.
Yeah. I agree.
Okay.
I will say, okay, so let's go. I will leave the traditional NOS aside because it's not our subject. And let's go and discuss, Cumulus as an example for the commercial NOS, Linux-based, and I will take Sonic as an example for the open NOS. So Cumulus brought basically, or not brought, or maybe made the segregation approach what it is today. Now, if we think about it in a blob of servers where the operating system is locked into to the vendor, and the applications are locked to the vendor. And if you want to add a service, you need to call the vendor. Obviously, this is not happening in the data center today. Today, in the data center, you are buying basically a commodity hardware. You're server is not relevant anymore, this blob paradigm, but in the switch it is. But in the last years, we see that it's changing rapidly also on the switch. So also on the switch, and this is the message I guess from Cumulus, is that, choose the best hardware you want, choose the best operating system. Cumulus will prefer if you choose those, but theirs, obviously, but you can choose. And on top of that, you can actually use the power of Linux and install the packages by apt-get, by uninstall. Just choose whatever you want, put it on Linux, and run your switch. You can obviously manage your switch as Linux, meaning system APIs by Linux, files, whatever. This is how it started. But as I said, there was a journey with Cumulus also where basically they updated another service, which is called the CLI. It's called NCLU with the Cumulus. So we also have a CLI. Customer can choose if to choose the CLI or not. It's their choice. So this is the disaggregation approach, and I guess disaggregation is a lot of time is kind of related to what we call open networking.
Okay.
But still, Cumulus is a commercial NOS. It means that yes, it's Linux, it's not fully open source, and there is a license part. Okay, we need to mention that. One thing I would say about Cumulus that they actually brought the protocol stack, which is one of the most important components on the switch, to the place it is today. And this is a huge kudos to Cumulus to do that. So FRR today, in my perspective, is one of the matured, strong protocol stack in the industry, and this is definitely something we can say Cumulus had a big part of it.
Okay.
Now, if we go to the open source, and let's ask some question, Anton. Let's ask, for example, why? Why in the first place? Why in the first place open source NOS in the data center? So some of the answers are actually related, are kind of similar to the server side. First of all, no vendor lock, right? It means competition. It means higher ROI. Hardware is developed more rapidly because of considerations around the open source projects. Accelerated software development because of the community. When it comes to total part, so it costs less. There is no feature fees. Also, on the operation expense, there is a big advantage when using open source Linux-based operating system. Basically, as I said, power of Linux, the DevOps, everything that is related to Linux is relevant also for the switch operating system. That brings obviously some cost reduction also there. And also, we need to think about it, the older traditional operating system, like Nexus, COS, Junos, are pretty old one. So they were developed long time ago. And on top of that, more feature were added and so on. While the open source options are really modern operating system. They were built and architectured not a long time ago. So for example, if we take Sonic as an example, it's a containerized based operating system. You're using modern databasing like Redis and other options. So it's kind of built more modern way. It gives some advantages also there. So those are the reasons. Yeah.
No. Go ahead. So I just I have some questions, but I'll ask once you finish.
Okay, no, sure. So as I said, I will bring Sonic as an example for that. Sonic started as a Microsoft operating system for the Azure, Microsoft Azure, one of the biggest, maybe the biggest data center in the world. It's really huge. If you're looking at the market cap of the top 5, what we call web scale companies, Amazon, Microsoft, just to give you an idea, the top 5 are actually covering 50% of the market cap of the entire switch market in the world. It means if you are actually collecting all the databases, data centers in the world, from the smallest one to the tier 1, tier 2, telco, everything, and compare it to the top 5, it's kind of equal. Okay, so this is how huge is this market. Microsoft decided that because it's so huge, the networking team said, okay, we cannot continue and be based on the traditional operating system from Cisco and other vendors. We need to think about how to reduce costs dramatically, how to control our destiny. And they came with Sonic, and really rapidly, they actually released it to be open source. And today, on GitHub. There is nice documentation, wiki, all the source code is there, projects, updates, everything can be found on GitHub regarding Sonic. So today it's a fully open source operating system.
I have a question here regarding the Sonic, right? So I think when I was doing some researches some time ago, then Sonic was based on the Quagga, but recently they also moved to FRR. Actually, I think just a couple of months ago. What was the reason behind? Because I assume Quagga, at a certain extent, was covering all the needs, but changing Quagga to FRR definitely should have some driving force behind. Do you have any idea why it was done?
That's a good question. I'm not sure exactly. I can only assume.
Okay.
My assumption is that Cumulus did this forking or branching to FRR because at some point there was an understanding that with Quagga they could not reach to a point where they can actually run VPN or actually develop it in a good way. So this was the forking to FRR. I think Sonic, in that sense, once it got out from the context of Azure to a bigger context of other companies using it, there are more and more needs that came from even from the enterprise market. For example, MLAG and obviously VXLAN and other features that needs to be done there. And I presume, this is only my assumption, I must say, I don't know, I don't have the details, that the decision to go to FRR was because of that, because FRR could fulfill those needs.
Okay.
But that's a great question, because I want to talk really about maybe, and I will ask the question afterwards, okay, why open source? Why now? But maybe even more important, for whom? Because Sonic is not for anybody. And one of the reasons is exactly because I explained right now, because of your question, because the reason Sonic was built, for whom the reason for built for the first place, which is Microsoft. Okay, so there are some constraints there.
Okay, let's take a look.
To this discussion about open source NOS and specifically Sonic. So this is a snapshot from an Azure blog, basically, where they kind of posted or pictured the different layers of the operating system and the different vendors that are involved. So first of all, Mellanox is, I think, number 2 in the contribution to Sonic. But beside of that, you see that the only logo that repeats itself in the different layers is actually only Mellanox. And the reason for that is because we are, first of all, a silicon vendor. So we are an ASIC vendor. We are doing ASIC. So this is why we are placed in the ASIC level. We're doing switches, also the systems. So this is why we are also there. But we are also investing a lot in developing software, application, and services on top of Sonic. And this is why we are also on the list. So you'll find us, this is kind of funny, you'll find us near Docker, but also near Marvell. It's kind of, and also near EdgeCore, which is an ODM for Whitebox. So we are kind of placed in different layers. We have kind of a very good understanding about this operating system. And yeah, I think, I mentioned it now, Anton, regarding the questions, why Sonic now? You can also say why open source now, but again, I want to focus on Sonic because I think it's kind of the popular open source option today. Built for Azure, we need to say that. But since then, it became an open source. There is a very large ecosystem around it. You saw the vendor logos. So a lot of vendors are involved. There is a lot of investment around it. The feature set hit critical mass. It actually became a valid operating system to deploy in the data center today. And the proof of that is that it's actually went outside Microsoft. So we can obviously mention the big ones, LinkedIn, Alibaba. I cannot mention, but there are customers in EMEA. Part of them are Mellanox customers, part of them are not, but there are customers in EMEA, medium and big ones, that are actually deploying Sonic. And one important thing to say is that there is also a support program around Sonic. So there are vendors that actually provide support from ASIC to the protocol, everything. So it's kind of an enterprise level support that is offered also for open source option like Sonic. and this is very important.
But you have mentioned that feature set have like critical mass, which is valid not only for Microsoft, but still from their list of the company who are implementing this Sonic. I presume that all of them are, if not hyperscalers, but very close to, right? So it's I mean, to get the benefit of the Sonic, or you might really, or I mean, to see the benefit of the Sonic, you need to really have a certain scale, isn't it that?
Wow, you are absolutely correct. So it's a very good question, because you know this joke, I have a slide about it. So this is the slide. Yeah, that's a very good question. You are totally right. You actually touched the right point. So yeah, we should go Sonic. So before I'll touch the scale, I would say that you need to be serious about open source. You cannot not be serious about open source and go Sonic. And you need to be serious about doing automation. And you need to be serious about the scale, as you mentioned. Why is that? Because there is kind of a threshold where the overhead of using an open source operating system in the data center, just it's not enough, you know, because there will be an investment. There is no question. But if you have the certain scale and you are putting the investment, and you have people in the company that are capable to do that, then you will enjoy it. Then you will see the benefit in the cost when it comes to operational expense, on the capital expense, because every switch that you're going to add to your data center, you're going to pay also only the hardware part, obviously. And every time you are going to add a switch to the data center, everything will be so automated that it will be so easy to do it. So in the long term, with the right scale, Sonic is a very good option, very good option. And the typical use cases today, I must say today, is layer 3 everywhere, including the host itself. It means dual homing, no MLAG on the top of rack, a very static configuration, not very shifty and changing. This is the typical use case today. Again, because this is the use case of the big top, you know, what we call basically Azure, basically designs, a parallel class. There are many names for that. You can see the picture here, but the parallel class option, very static, very layer 3, everything is BGP. But, and this is very important, there is a change in the introduction of FRR inside. It can be even different. There are more and more contributions into the Sonic that allows to do more things, and I will explain at the end what exactly can be done. One of the things I done myself, but obviously people also invested in different places in the world in more application inside on top of Sonic that allows to do more than that.
Okay.
And maybe the more important question is, who should not touch Sonic? So if you are looking for a turnkey kind of solution, let's say 2 racks, nobody in the organization really familiar with Linux or DevOps, then I think that, you know, it's not really the best fit for those kind of deployments.
Okay, I think that explains a lot. I mean, so that's really, it is good. And actually, I fully agree with what you're saying. So in order to deploy any kind of open source, but also from my experience, what I see, you need to be prepared to do a lot of development and support job, but typically is outsourced to their professional services. And in this case, like you're doing professional services yourself, which is on the one hand very interesting, but require a lot of attention, right? Like a lot of efforts. I think that yet, unfortunately or fortunately, the open source is not yet for everyone.
That's true. That's true. But more and more and more companies are doing it. Again, with a certain size, it doesn't have to be huge, by the way. We have customers in EMEA which are really not very big, but they have a couple of strong engineers. They are doing basically layer 3, and then it fits perfectly, and they're enjoying it, and they're saving a lot of money. So it really needs to fit to the right organization.
Okay.
Now we're going to kind of jump for 2 slides to a different subject, but actually will not. So I'll there is kind of the protocols declining, and there is the telemetry features that are increasing very rapidly. Why is that? Now, if you think about the big data centers, Yeah, some of them will do only BGP. But even if you're looking at non so big data centers, what exactly you are running there on the protocol? You're running maybe an underlay of, let's say, eBGP, or kind of, right? And then on top of that, MPBGP, which is called VXLAN VPN, and maybe MLAG. And that's basically that, and so, and if you are doing, for example, unnumbered, or using those features, then it's really, sometimes it's so easy to configure a spine or a leaf on data center. It's really easy, and if everything is automated, then it's not error prone. So today, actually, to build a leaf spine using even VXLAN, it's not so difficult. It can be done, and you know what? It will work. But then what? Then starts the tedious part of actually understanding what's going on. And maybe obviously there are tunnels, and if there is a logical network, maybe double tunneling, and if you are using RoCE or RDMA, it's even getting complicated. And so this is the reason that we see a decline in the protocol, or the features of protocol that are part of the NOS. So no more Trill, no more private VLAN, no more all those spanning tree variants, no more all those things. But, and again, I want to make sure emphasize we're talking about the data center, right? This is very important to say. So very limited, but on the other hand, SNMP or counter-based telemetry is not good anymore, and the industry is going through a phase where it's moving to real-time telemetry, streaming telemetry, to actually be able to understand what's going on in the data center. And there is one telemetry that Mellanox provides, we call What Just Happened. Let's look at it as kind of a very top edge telemetry, one of the newest telemetry, real-time data plane telemetry. In a nutshell, what it does, ASIC itself is able to actually explain if it's doing something wrong. So if it's dropping a packet or there is some anomaly in the data plane, immediately it actually reflected to a database, InfluxDB or whatever, and eventually it can be also presented in different tools for Grafana, Kibana, so actually you can use TIG or different other tools, or various of tools to actually present this information. So immediately when a packet dropped, you will see a line with the timestamp, with the full 5-tuple or 12-tuple, the reason, and even sometimes the solution. So this is what we call a very advanced telemetry feature. This is one example. Now you can think about it, okay, and say, wow, this is a great feature, but I guess, the vendor will lock it to the NOS, and it will be available only in operating systems such as EOS or Nexus or Onyx. Now, here's the thing. This feature actually exists also in Sonic. So you can find it in Onyx, obviously. In this example of Mellanox, you can find it in Cumulus, but you can also find it in Sonic. And this is exactly what I wanted to say. I wanted to say that going open source doesn't mean you need to be compromising. And this is very important. Going open source doesn't mean you're going to, do minimal things. No, you can enjoy all the best things that are out there. And what just happened is just one option. Microsoft itself has its own streaming telemetry, which is actually a project inside Sonic. And you can also enjoy that. So it's not like that. You actually are going to enjoy more and more modern features that are also available in the open source option.
Okay, no, it sounds really interesting. I mean, so the world is different. I mean, for the guys who was never working in the software development and all this Linux forwarding, but on the other hand, I think even for me, though I know like a bit of these things give a lot of great insights to understand what is happening beneath when your switch is booting, how it is operating. I think the troubleshooting is getting more funnier when you need to troubleshoot not only the operation system or protocol stack, but also Linux as well. On the other hand, their knowledge of the server or the Linux really easy to reuse here, and that is where it makes sense to reuse them.
Yeah, I agree. And I'm going to finish maybe with explaining a even more open option. So you see on the right hand, everything is kind of green. So I will touch it really a bit, and I would say that if we said that even in Sonic, really open source or not, the specific vendor kernel devices of the SDK, let's say.
Mm-hmm.
Then if you go right, there is an option which is called, it was called switch dev. It's not called that anymore, I think, but it's basically a Linux driver, Linux device driver for a switch.
Mm-hmm.
So what does it mean? It means that like, in the server, you are placing a NIC card inside, you need to install a driver. And after you're doing that, you do fconfig IP link, just choose any system call by Linux and control your NIC card. And this is the same idea for switch dev or Linux switch. It means that you have a hardware, a switch, you choose your own Linux. You're not bounded to the Sonic Debian or Cumulus Debian. No, you can choose whatever you want, update the kernel, install the driver, do fconfig, you will see 32 ports or 48 or whatever, 32 ports, and just start to do install on apt-get and get your system calls, Linux APIs, and control your switch. So this is an option. It's deployed. We need to say that it's not something, it's imaginary. It's actually deployed in different places, including Europe. A big customer, for example, in Russia is doing a switch dev. But one thing that is very important to say, this is not a network operating system. This is not a NOS. This is a driver. That means that if you're going that way, once you did that, that's perfect. But if you want to run a protocol, for example, BGP, you need to download FRR or BGP or Bird or Go BGP or whatever. You need to actually download the protocol stack. And then if you need a database, you need to build your own database. And obviously there are different aspects of network operating system. For example, controlling the power supply, system CTL, you need to actually manage it. So basically you are building your own operating system. This is the second level after Sonic, basically building your own operating system based on your own Linux, based on your own needs, based on your own demands. And you can understand from that, Anton, that means that here you need to be maybe the scale bit higher. You need to have maybe other consideration. Maybe the team will need to be bigger. So this is maybe another consideration, but I just wanted to mention that. There is a project which is called DENT, which is led by the Linux Foundation. And the members are Mellanox, Marvell, Cumulus, I forgot, Amazon, obviously, the big one. And I hope that I didn't forget any other one. I'm sorry, but there are others, I guess. And this project is a very new project, but it's based on a very new product, which is called Linux Switch or Switch Dev, that was developed by Mellanox and Cumulus.
Okay. So, I mean, the further development could be even more just pure software Linux development. I mean, if the company is going this track, which is good because I think it's always cool to have a lot of opportunities, and then based on your needs or capability to decide whether to go in close or commercial, semi-open or fully open, or open meaning building whatever you need on your own needs. It's really interesting that there is such capabilities.
So you know what, I really agree with you on that, Anton, and you touched exactly what I wanted to say. I wanted to say that the thing about open networking, it doesn't mean that you need to go to the DENT way. You can also go maybe to the Onyx way or other option, but it means that you have the choice. And if you have the choice, you can decide what's best, for the organization and what's best for the workloads and what's best for everything. So the choice here is the big word. So I will finish with 2 slides with a question first. Yeah, what's stopping us to do open source NOS? So a guy would think, it's not matured. I need 10 developers to make it happen. Who will support me? Who will fix the bugs? Usability, I'm compromising here. Even a POC, how can I start? So those are the questions, and the answer is that, well, I think I answered, why at the beginning. There is an ecosystem which is so big, and there is a large base of deployment already, and a lot of contribution. But more than that, there is support contracts today for open source that actually covers everything from the ASIC up to the protocol. The platforms that are supported, the hardware platforms that are supported under the open source, are the best in class. the best ones. So Mellanox is just one of them. But if you think about those white boxes that I mentioned in the beginning, those white boxes, the same white boxes that are sold with the branded name like EdgeCore, is actually an Acton company that actually provides the same box to vendors that you are all familiar here, including you, Anton, the traditional ones, the Cisco's and the Aristas, the same boxes, just branded as white box. So best in class platform, that means you're getting performance and everything. You're not compromising also there. And again, because there is a large community of vendors around it, it's easy to consume. There is a starter kit, there are training programs, um, and definitely it's not so difficult to do that. You don't need 10 developers, not for sure not. I know companies that also has 2 developers and even 1, and it's working.
Okay, now I think it is really great exposure of what's going on in the industry, and thanks really for doing this for us.
Cool, and I will finish with that maybe, and that will be my last slide. So kind of the nirvana or the way that I'm looking at it. So yes, today, if you want to run, for example, VXLAN VPN topology with MLAG or dual homing or multi-homing on the leaf. So Sonic will not fit to the leaf side. It will fit maybe more on the spine side, because you can enable EVPN address family and actually activate Sonic on the leaf. You still need the QMOS. But guess what? They are using the same protocol stack, right? So it's not so different. They are both Linux based. One day, maybe Sonic Switch Dev will go also to the leaf. We'll be able to offer multi-homing and other features that will fit also the tier 0 or leaf or top of rack level. And we should not forget, just to close the circle, that yeah, everything is cool on the software side of the device itself, but once going with this approach, it also means no locking on the cables, no feature fees. Everything still needs to be open on the hardware and the software side. And this is what I call open networking at the end of the day on the data center.
It's a way to go. I think it's challenging, but definitely very interesting. I think we're right now at the point where the industry has started changing from a traditional, like monolithic vendor-driven, to a world where you could choose which path to go. Obviously, it's possible, as we discussed, go to the past traditional one, getting like one-stop shop from their whatever vendor, or there is another extreme where you could build everything, perhaps besides the switches, on your own. And the truth is usually somewhere perhaps in between, depending on the company, depending on the size, depending on the needs, and depending on the ambition. It's also important, because many of things are done just because the people kind of want to do this, right? So, and getting the proper toolkit, I think it is the basis to kick off this journey.
Agree. I think at this point, I would like to thank you, Anton, for your time, for the opportunity to present here. I must say that I myself are learning a lot from your webpage and blogs. Definitely learned some things. So thank you very much for this opportunity.
Thank you very much, Avi, for your time, for coming. I think it's really interesting presentation. I myself learned a lot, and it's kind of, for people who are not familiar with the topic, a very, very helpful starting point. Thank you once more for your time, and see you the next time.
Thank you.